All right, good morning, folks. This is Mike coming back at you with another video on Intro to Algebra. In the previous video, we wrapped up section 4.1. We talked about power rules for exponents and product rules. In this video, we are going to continue talking about properties of exponents, and we will be talking about the quotient property or the quotient rule. Just as a quick recap, if you take any number that's not 0 and you raise it to the power of 0, you're going to get 1. And then if you take any number whatsoever and you raise it to the power of 1, you are going to get that number that you had. So a to the power of 0 is 1, and a to the power of 1 is equal to a. Now, in the previous video, when we dealt with exponents, we had only dealt with exponents that were positive, and they were positive whole numbers. So what if you have an exponent that's negative? What if you have an integer exponent where the exponent is negative? We don't typically like to see things and work with things that have an exponent that's negative. So how do we take an exponent that's negative and make it positive? Well, we can do that, first of all, and how we do it is we sort of change where it is in the fraction that we have. So if a is a non-zero number, you'll see why it can't be 0 shortly, and n is a real number, we'll be focused on integers, but it can be any real number whatsoever. Then a to the power of minus n is equal to 1 over a raised to the power of n. And similarly, if you have 1 over a to the power minus n, that's the same thing as saying a to the power n. So the sort of informal way that you can think of this is if you have the negative exponent that's in the top part of your fraction, take that quantity that you have, send it down to the bottom of your fraction, and then that exponent will become a positive. You will remove that minus sign that is in your exponent. If you have a fraction and the negative exponent is in the bottom, move it up to the top, and take that term and move it up to the top, and then the negative sign drops out, and your exponent is now positive. You can sort of think of it as the negative exponent on a base. Think of that as a kid who has been bad, and you want to send him down or send her down, whoever, to the other side of the house, if you will, or the other part of the house. If your kid is upstairs and has been bad, send him or her down to the basement and they'll be good. If your kid is in the basement and he or she has been bad, send them up to the top of the house and they will be good. It's a very corny way to think of it, but sometimes the corniest things help you remember it. So we're going to rewrite each of these exponential expressions so that the exponent is positive. So here we have 5 raised to the power of negative 6. Okay, well, again, we can look at this as a fraction. We can think of this as this thing over 1. So the kid is in the upper level of the house and is being bad. So we send it down to the bottom. And then we said when you send it down to the other side, or when you send it down to the bottom or top, you remove the minus sign that is on that exponent. So we have 5 to the power of 6 on the bottom, and we put 1 over that. So 5 to the power of negative 6 is the same thing as 1 over 5 to the power of 6. Okay, 1 over 7 to the power of -3. Here, our kid is in the basement of the house, and here she is acting up. So we need to send them up to the top. We need to send them up one level, and that will make him or her be good. That will remove that negative sign that we have in the exponent. So this is the same thing as 7 raised to the power of 3. We could say it's 7 to the power 3 and then divided by 1, but we know that it's the same thing as just saying 7 raised to the power of 3. These next two problems are very good problems to showcase what is essentially the same property, but it's just kind of a special case of it. What happens when your base is a fraction? So what happens when your base is a fraction is, yes, we can take this guy and send it down to the bottom or send it down to the basement of our house. So let's write that out, but we're going to see that it just doesn't look very nice. We're going to have 1 over 5 over 8 now raised to the power of +2, not -2. Right? But this is ugly. This is not the friendliest form. We don't really want to look at things like this. So how can we rewrite this? Well, I can say, by using properties of exponents that we learned from our previous video, that the bottom is 5 squared divided by 8 squared. And we know that if you divide by a fraction, that's the same thing as multiplying by its reciprocal. So 1 over 5 squared divided by 8 squared is saying the same thing as 1 times 8 squared divided by 5 squared, which clearly is just 8 squared divided by 5 squared. And that's the same thing as 8 over 5. That whole thing raised to the power of 2. So we see that when our base is a fraction, if we just take the reciprocal of our fraction and we flip the top and bottom, that will make the exponent positive. That will remove the minus sign that we have there. So the sort of technical mathematical way that we can state this property is to say that a over b raised to the power of, say, we'll go minus n for the sake of being consistent. A over b raised to the power minus n is the same thing as b over a raised to the power of positive n. Again, this is really just sort of a special case of the general property, and we sort of work through why. So use this property, try the fourth one on your own, and we will go through it together in class. Okay, the other big property that I want to talk about in this video, back in section 4.1, we multiplied exponential expressions where the bases were the same. Now, what happens if we divide exponential expressions where the bases are the same? So, what is, for example, what is 7 to the power of 4 divided by 7 to the power of 2? Okay, well, again, we're just going to use the basic definition of an exponential expression. 7 to the power of 4 is 7 times 7 times 7 times 7. And 7 to the power of 2 is 7 times 7. Okay, well, here I see a factor of 7, and I see a factor of 7. These guys will divide out to 1. And I have another factor of 7 on the top and a factor of 7 on the bottom. Those guys will divide out to 1 as well. So I have 1 times 1 times 7, which is just 7 times 7. And then I have 1 times 1 on the bottom, which is 1, and division by 1 doesn't change anything. So I'm left with 7 times 7, or as an exponential expression, 7 to the power of 2. So it seems like, when comparing these two quantities that we know are equal, it seems like if you divide two exponential expressions where the bases are the same, you still have the same base, but it looks like your new power is simply the difference of the two powers. The power that you had on top minus the power that you had on the bottom. And that is generally true. For any non-zero number a, and any numbers b and c, a to the power of b divided by a to the power of c is equal to a raised to the power b minus c. So what this is saying is when you divide exponential expressions where the bases are the same, you take the difference of the powers. So multiplying exponential expressions with the same base, add the powers, keep the same base. When you are dividing exponential expressions that have the same base, keep that base, but subtract the powers. All right, so we'll go through some samples here. First one, start off nice and slow. X to the power of 4 divided by x to the power of 5. And if any of these find that we have any negative exponents, we're going to rewrite this so that there are no negative exponents. So here, I am dividing two exponential expressions. Bases are the same. They're both x's. So I'm going to take the difference of these powers. X raised to the power 4 minus 5. And 4 minus 5 is negative 1. But this is a negative exponent. We said we don't want any negative exponents in our final answer. So we're going to use our other property that we learned in this video and rewrite this as something with a positive exponent. Here, our kid has been bad, and he or she is in the top part of the house, so send them down to the basement, and they become good. So I have 1 over x to the power of 1, or 1 over x. Okay, next one here, I have an x times a y cubed on top divided by y to the 7th. So this one, clearly a little bit different. We see we have y's on the top and the bottom. We have an x on the top but no x on the bottom. So you may be wondering, sort of what do we do with this x here? Well, keep in mind, we can only use this property when we are dividing things that have the same base. If an x is showing up on the top but not on the bottom, then we just don't mess with it. We don't do anything with it. We just leave the x as it is, and we focus on y to the third over y to the seventh. These bases are clearly the same. We are dividing these things, so it's going to be the same base, that's y, raised to the power that is the difference of these two powers. Power on top minus power on bottom, 3 minus 7, which is negative 4. But again, we can't have negative exponents in our answer, so I need to rewrite this. Now, the exponent of negative 4, again, is only on the y. It's not on the x. So the y to the power of negative 4, this kid is on the top and they are being bad. So send them down to the basement and they become good. So I have x times 1 over y to the power of 4. And you can see that is the same thing as x divided by y to the power of 4. Fourth one, I'll let you try on your own. We'll go through that in class. I do want to go through this one here. Clearly, a lot more happening here. So 2 times x times y divided by 8 times x cubed times y squared. Okay, I see numbers on the top and bottom. Perhaps those can be simplified. I see x's on the top and bottom. We can use some properties of exponents to simplify that more. And then I have y's on the top and bottom. I can use properties of exponents to simplify that more as well. So let's sort of focus on things that have the same base. I have my numbers, my constants, 2 divided by 8. I have the x divided by the x cubed, and then I have the y divided by the y squared. So let's work with each of these things separately, and then we can multiply those together. So I have 2 divided by 8. 2 divided by 8 is the same thing as 1 divided by 4. All right. X, which is the same thing as x to the 1, divided by x to the third. Bases are clearly the same. We're going to use that quotient property to say that this is x raised to the difference of those powers. And again, it's top power minus bottom power. Similarly, with the y's, y to the power of 1 divided by y to the power of 2. Bases are the same. Quotient property says take the difference of those powers. Clearly, 1 minus 3 is negative 2. So x to the power negative 2 and y to the power of negative 1. And in each of these cases, the child is on the top and is being bad, so send them down to the bottom and they will be good. So you could leave your answer like that, or multiplying the tops and multiplying the bottoms would leave you 1 over 4 times x squared times y. So as I said, I'll let you do this one on your own. You should not have any trouble with it given the other 3 problems that we did. Guys, this concludes our video on section 4.2, the quotient property for exponents. If you have questions or comments, be sure to reach out to me, guys. Emails, in-person office visits, phone calls, telegrams, SOS bonfires on beaches, whatever you have to do. Until the next video, take it easy, guys.